Good morning. How are y'all doing? Thank you for being here. We've already had two great examples of what a data-driven app's all about with our survey, and I think that's pretty cool. So we're very, very excited to have you here. We've got a lot of great speakers. We've got a lot of great content. We've got a lot of great sponsors, and the ecosystem is really thriving and very engaged in this conference. And we couldn't be more appreciative, and as you know, we can't do it without the ecosystem, the community, and every one of you, because without that overall open source model functioning holistically, the tech breaks down. And I think that's what we're so excited about this conference in particular. This is the 11th Hadoop conference in San Jose. It's about number 17 total. And what this conference has always been about is bringing the community and the ecosystem together to talk about what we're going to build and how we're going to innovate how data is managed. And it's been a very, very powerful model when the community and the ecosystem come together to talk about how the innovation of the tech evolves and how we're going to go do that. But what I want to focus on a little bit is why we've done it, because all of the phenomenal work that's gone in to creating a big data platform for managing the world's data and really transforming how data is managed across the IT landscape for the next 15 or 20 years has really begun to create critical mass in terms of use case and value drivers. And it's really begun the shift of moving data away from the legacy siloed platforms toward a modern data architecture. And what that's led to and what that's enabled is very much a transformation of how data-driven business models can emerge and function. And what we're seeing now is the biggest transformation of business models since the Industrial Revolution. You know, we've spent the last 30 years trying to optimize a very procedural approach from the enterprise and how they build a product, how they sell it to their customer, and then how they optimize their supply chain. And it's been very procedural. You have to do A, B, C, and D, and you can't optimize any of that until A, B, C, and D have been run through the gauntlet, and then you figure out how can we tweak and adjust. And in the new world of connected communities, we now can bring very much transparency and high velocity between the enterprise, the customer, the product, and the supply chain. And we can understand in real time how our products are being used, how well they're performing, how much is the customer engaged, are they using it correctly, do they misunderstand it, did it break, are they frustrated, where are they in their buying cycle? And by having a connected community, we can transform the business models and how the enterprises engage with their customer, with their product, and drive efficiencies across the supply chain. But really at the center of that starts with data. And Hadoop, and the work this community's done over the last 11 years, has given the modern data architecture the ability to emerge. And it started with the work in the community, first and foremost, to bring all the legacy siloed data together under one common platform. So to take the transactional ERP, supply chain, HRM, SRM, and to be able to be a central architecture now to bring that together and get 360-degree insights and real-time insights about the data and the customer and their products. But it also gave us then the ability, through the work in the community, to bring that data, all the new paradigm data, the mobile, the social, the clickstream, the IoT data, and to bring it under management so that we could gain useful insights and do it with an economic that made it pragmatic to bring under management and to drive that interactive insight that created new engagements models for how we took product to market, how we made decisions about building temperature, about patient care, about logistics and transportation, how supply chains move. And that was the huge first step of the work that the community did to make Hadoop truly an enterprise viable data platform. And it has become the de facto platform for managing the new paradigm data sets, as well as being the central aggregation point for the siloed legacy transactional apps. And that now that we have all this data under management at a great economic, we now have the first step to enabling a modern data architecture that moves us away from that procedural, step-to-step siloed world, fractured world, to now being able to manage the entire life cycle of data from the point of origin until it comes at rest. And so at the core and the center of gravity is Hadoop and our big data strategies. But over the last 5 years, or 4, 5, 6 years, we've seen the advent and explosion of data that's coming at us from all the streaming data sets, all the IoT and sensor and component level data that comes into the enterprise about what's happening with the product, what's happening with our customer, how's our supply chain performing, right? We've had the advent and the evolution of then, now that we have this massive amount of data from all these different sources and we can bring it under management, we then can apply AI and machine learning models onto that so that we get always the best in class outcome for the most desirable response that we're trying to get to for the best in class business decision or customer care or logistics movement, right? We also obviously, with all that the cloud has evolved to become and offer as an architectural tier to process, store, and manage data, we now have the ability and have to be very mindful of how we apply the Hadoop capabilities into the modern architecture and leveraging every tier, on-prem, private cloud, multiple public clouds, and how do we make sure that we bring all of the different data sets together on one common platform. One of the companies that I really respect in what they're doing of mobilizing their customers is Marriott Corporation. And they're one of the 4 leaders in big data. And interview recently with their CEO, Arne Sorensen, and a great visionary. And he really summed it up well, I thought, in this interview. And he said, we're in an absolute war for who owns the customer. There's so many ways and abilities for our competitors to disintermediate our relationship with our customer because they have the access to know what our customer's doing at any point in time in their travel cycles. And their strategy and to win their customer war is all around their platform strategy and how they manage the overall life cycle of the relationship with their customer to and through data. And I think we'll see this time and time again, is what's going to separate the winners from the losers with these data-driven business models will be how the data's applied, how it's leveraged, and how quickly the enterprise can transform themselves from these very procedural, siloed interactions to be able to have real-time visibility and real-time interaction and give them the ability to manage the entire life cycle of the relationship with their customer through the data interactions that they're going to have continuously. And what that's going to give them the ability to do is create connected communities to bring real-time visibility between their customer, their product, and their supply chain. And we eliminate the siloed barriers of having to be very procedural to now being able to be very prescriptive with the best-in-class machine learning and AI models that deploy a prescriptive action as a condition or an evolution with the relationship happens. Great example of this is one of our customers. And I really want to encourage you later today, Tim Leonard from Trimble is going to be discussing their use case and how they've deployed it. He's done a tremendous job. He's a great visionary. They've done a tremendous job executing on putting a connected platform strategy in place that's completely data-driven. And I want to not steal too much of Tim's thunder, but they're a $2.65 billion company headquartered in Sunnyvale, operating in about 35 countries. They manage 4 million trucks a day and about $31 billion of freight that moves across their networks annually. And they're using the Hortonworks suite of products from NiFi, HDF, and HDP to manage the entire life cycle of their data. And they're driving that into machine learning models that leverage blockchain as the backbone for this. And what they've done is they've really transformed the overall logistics process from being completely manual to being automated and digital through that entire life cycle. And it's opened up a number of new product offerings that they've been able to deploy and new models that they've been able to allow their customers to embrace and engage. And you'll hear about the initiatives from the farm to table, from the food safety compliance guarantees that they've been able to drive. But they've done this all through very much data-driven and machine learning, very prescriptive use cases and engagement with their customers. And so now what we have to look at is, if we're going to have a modern data architecture, what's involved in that? And the requirement is we've got to be able to connect in real time the customer, the product, and the supply chain, and bring complete transparency and immediate visibility into each of the engagements that they have through the procedural cycles. And so we have to bring data under management from the point of origination, off the click stream, off the sensor, off the component, on the rolling iron, and make sure that we're managing that through its entire life cycle and can take prescriptive processing action as an event occurs, a condition changes, and apply the best in practice result against that. And then we bring it at rest and be able to drive the insight and to have the long tail view of how that historically applies against our model and our ecosystems model. And then we want to have the ability to deploy that workload and that application on the tier that's most financially and architecturally pragmatic, whether that be on-prem, whether that be on a private cloud, or whether that be across multiple public clouds. And so now I'd like to bring our co-founder, Arun Murthy, up, and he's going to talk about the how we enable you to do that, and with which of our products that we're doing this with. And then through the course of the rest of the day today and tomorrow, you're going to see a number of use cases to show you how to enable these, this modern data architecture. So with that, Arun, if you come up and join me. Thanks, Rob. Thanks. Yeah. Thanks, Rob. Morning, everyone. Exciting time. You know, Rob talked about what we're doing from a business context in terms of how we're enabling the customers to get value out of this data, right? I'm here to talk to you about how we do this on multiple tiers, especially with public cloud and private cloud showing up increasingly in the enterprise landscape, and how we want to help customers leverage it. While I do that, it's also, like Rob said, it's important to remember when I talk to customers about the cloud, I generally try and help them understand that, yeah, cloud's a really important part of your strategy, but you have to look at it in the context of your overall data strategy, which also happens to be your business strategy, right? So let's take a look at how we've done this today. Our customers, start off with HTTP on-prem, and you see that on the left. And I'll talk a little bit more about sort of what I call the interaction model with Hadoop. The interaction model with Hadoop was you'd actually walk up, if you were the end user, you were doing analysis, you were doing SQL, you were doing data science, you'd walk up to an existing large shared multi-tenant cluster, and you'd submit your applications, right? So in some ways, from the end user standpoint, it was serverless, because the end user himself wasn't actually dealing with the infrastructure. It was a team who happened to be at the enterprise doing that for you, the IT itself, right? So when
initially they started walking to the cloud, they kind of started to forklift that architecture and run the same architecture on the cloud, right? And in fact, we had some customers who would even run HDFS on ephemeral instances running in Amazon, Microsoft, and Google, right? So what we helped them understand that we want to make sure that you leverage the pieces of the cloud, the architectures in the cloud, and the services in the cloud. And a great example of that is storage, right? You want to do the best to be able to leverage the cloud stores because they have a lot of benefits, availability, disaster recovery, geo-partitioning, and so on, that you want to leverage. So we kind of help them understand that going from on-prem to cloud, there is an IaaS architecture, which you see in the middle, right? And HDFS still there to actually do some temporary processing and so on, temporary storage. But really, you want to be using S3, ADLS, GCS as the storage of record, right? From then on, again, the interaction model started to change because as we went through the journey, we together with the customer understood that you can actually now leverage the economics in the cloud significantly, in a significantly different and more efficient way. And one of the ways to do that was to actually spin up workloads only when you wanted them and not run large multi-tenant clusters, right? That is kind of the architecture we landed in at the left here. So then what happened was, when you do this, you're spinning up these workloads up and down, and your data is, sort of the storage of record is, S3, ADLS, WASP. Then you want to have a shared services layer. We call it for the data lake shared services, right? Which is a box you see in the middle with some of the components from the open source projects, Atlas, Ranger, Knox, because these can now intermediate access to that data in the storage layer, and you can actually spin up the workloads as you go forward, right? So at the end of the day, what is interesting is that the interaction model with Hadoop itself changed, right? From on-prem to on the cloud. Now, equally importantly, we start to realize that wouldn't it be awesome if you could actually have a fabric that you could actually layer over all of this infrastructure that you have on-prem and on the cloud, and increasingly on multiple clouds, right? For a bunch of reasons now, whether it's geo-compliance, whether it's your favorite cloud vendor not being available in Asia or wherever the components are, there was reason to actually leverage not just your on-prem existing investments, but also multiple cloud environments. And that was the genesis of Data Plane, right? Which is, the idea was to connect it all together, have one fabric so that you can actually do consistent security and governance and actually manage all this infrastructure in one place through one pane of glass, right? And for us, Data Plane is two pieces. As the technology side of it is, the technologist in me is always, okay, we got to do the product, but you also have to build it in a way that you can actually plug in new services into Data Plane and take advantage of all the consistency that you get from a security and a governance standpoint. So great examples are, we start off with DLM, the Data Lifecycle Manager, which helped you move data from on-prem to cloud to multiple clouds and back on-prem. And then we added Data Steward Studio, right, which allows you to discover data and sort of manage and govern it, right? So Data Plane, like I said, is two pieces. It's the fabric, it's the product, but it's also the platform with which you can actually plug in new services. And a great example is the work we've been doing with IBM to kind of plug in DSX as one of those services, right? So as a result, we've kind of come to this architecture now where you have sort of this one interaction model on-prem, which is large shared multi-tenant clusters, but you have a different interaction model on the cloud, but we stitch it together using Data Plane and allowing customers to have consistent security and governance policies across all of these stacks, right? And that's particularly important, right? Because as you go from one cloud to another, or on-prem to on-prem, IT has just figured out how to deal with Kerberos, right? And now we got to deal with IAM on Amazon, IAM on Google. If we could actually layer that together in a consistent way, we feel like it'll actually, really add value and actually drive a lot more analytics both on-prem and on the cloud. And that's why Data Plane is such a big piece for us, that we've been investing so heavily for the last, couple of years. And as you probably know, we kind of went GA in October of last year with another rev, particularly with GDPR in mind, with DSS in May in Munich, right? So what is fueling all this, right? Again, we're talking about the vision, but what is also fueling this is the innovation that's coming from the open source community, right? And again, I've been privileged to be part of this community and be a member of this community for 12 years now. I cannot tell you how impressed I am, even myself, in terms of the amount of innovation that's come through, which is what we kind of put it all together and shipped with HTTP 3 this week, right? If you think about the innovation that's come in, we have comprehensive cloud support across the stack, not just the native drivers for the storage, but we've done a ton of work in Hive and Atlas and Ranger and a whole bunch of places, Spark, to actually give you consistent experiences both on-prem and the cloud, in spite of the fact that there are significant architectural differences, right? On-prem, you have co-located storage. On the cloud, you have disaggregated storage. On-prem, you have Kerberos. On the cloud, you want to deal with different security models. The communities work really hard across all of these to give you a consistent experience, and again, very thankful to the community, right? So some of the things that, again, excite me more are we've got containerization and GPU support in Yarn right now. What it means is you can actually now run really agile applications. You can have multiple versions of Spark, multiple versions of Hive, run TensorFlow with GPU support, and so on, right? Again, the SQL side, the Hive community has done an amazing job making Hive what I call a real-time database, right? Hive started off by being a SQL on HDFS layer, and it's now morphed and actually matured into a full-fledged database, including great security policies, security capabilities, column-level filtering, row-level filtering, and so on. And now you have things like ACID, and we did some benchmarks. We'll talk some more about it. Go to the talks. ACID on Hive now is actually as fast as not having ACID at all. It's phenomenal the amount of work that the community has put in, right? Because now you can actually do ACID both on-prem and on the cloud, on S3, on HDFS, right? Similarly, a lot of work, like I said, has gone into security and governance. The storage side is the same, right? The Hadoop and the HDFS community has brought in some key enhancements which matter at scale, right? Erasure coding. The fact that you can now have 1.5 replicas instead of 3 makes a massive difference, right? When you're dealing with tens of petabytes of data, as our customers are, right? Same thing with federation. So putting it all together, this is how we've been working, not just with the community, but also working with some great partners we have. Microsoft, obviously, has been a long-term partner. We just announced an expanded and extended relationship with them, where we're now not only doing HDI, which is sort of a prescriptive pass, but also now HTTP and data plane available as an IaaS offering, right, for a full-fledged HTTP experience, right? Similarly, we did a similar partnership with Google, with IBM. We've been doing a lot of work to actually bring in the IBM hosted analytics on their IBM cloud. So as you can see, whether it's on-prem, private cloud, or public cloud, you now have the full-fledged of all of these capabilities powered by the open source community, right? Very exciting times for me. So this is all here today, right? And as I stand before you, this is my 11th time here, I want to really kind of share a little bit of the vision of sort of where I see this going, right? And actually, this is a great time to get some feedback from you folks, because a lot of people here are not just people thinking of Hadoop, but people actually using Hadoop. We did a CAB yesterday, the Customer Advisory Board. Fantastic feedback. Very, very thankful. Very, very appreciative. So as we sort of stand here, I want to kind of put some ideas in your head and hopefully spark a discussion on kind of what comes next, right? To me, one of the key things is that as enterprises are sort of grappling with this expanded set of infrastructure choices, on-prem, private cloud, and public cloud, the interaction model is something that I feel we could actually do a lot more work on, right? Like I said, on-prem you have these large shared multi-tenant clusters. On-prem you have workload-specific applications, workload-specific clusters. How do we help bring this together? So one of the thoughts we've been thinking about is the future could actually look very, very interesting, particularly when you start to think of innovations happening in the technology space like containers, right? So we're starting to think, wouldn't it be nice if you had a consistent and identical sort of storage fabric on-prem and on the cloud? So on-prem, you have HDFS today, but on the cloud, you have S3, which is an object store. It would be nice to actually get something similar on-prem, right? Similarly, with containers, we can actually make it look like a container fabric, much like it look EC2, right? If you have that, you can actually start to layer identical architectures, both on-prem and the cloud, right? And actually get you the same interaction model. And the interaction model is really important because that's what drives usage of the platform, right? With that, hopefully, it sort of sparks some interesting thoughts in your head. Feel free to grab any of us, give us some feedback. We'd love to hear from you. And most importantly, enjoy the show. Have a great time. It's a great time of the year. Take as much as you take in all the technology, take in the weather too, and come in and give us some feedback. Once again, thank you for coming.